Hello students, and welcome to the lecture on Information Technology for Multimedia Communication. After this lecture, we will be able to learn the following objectives. Explain multimedia application. Understand the human perceptual system. Define analog representation of perceptual information. Discuss digital representation and coding of visual information. Explain the third representation and coding of visual information. Describe advanced multimedia coding standards. Define speech coding standards. Explain the text compression standards process. Communication has improved and evolved to facilitate our daily activities. In the 21st century, everything related to communication utilizes technology to send out or disseminate information to a wider audience. Information can be sent out in many ways. The inventions of cell phones, television, and other electronic devices are important in enhancing communication. Technology is the use of scientific knowledge, experience, and resources to create processes and products that fulfill human needs. Technology is vital in communication. Learn about multimedia application. Reflecting the generic or buzzword nature of the term multimedia is the range of applications that claim to be multimedia. Using some rough categorizations, one can sort multimedia applications into information systems, all systems whose main purpose is to provide information to a user or group of users. Examples of application areas are electronic publishing, electronic newspapers, hospital information systems, patient monitoring systems, multimedia patient databases, mixed reality surgery, navigation and information systems, shopping center, airport, and other public spaces offer touchscreen multimedia orientation systems. Museums, online catalogs using high-definition rendering of paintings, interactive online museum tours. The Virtual Museum in Victoria or the Paris Louvre Web Museum offer virtual reality museum trips. Remote representation. Systems which represent a user at a remote location. The representation can be either passive or active. That is, the user can either just receive information about the remote location and the actions taking place there, passive representation, or they can take part in the action and even influence the process at the remote location, active representation. Let's now learn about the human perceptual system. Perception system is a broad term that can refer to a variety of different concepts and constructs in biology and in technology that relates to perception. The visual system, for instance, is a human perception system that includes all of the components that are directly involved in giving visual information about one's environment. It includes, therefore, all of the parts of the eyes and brain that are involved in visual perception. The term perception system is also used in various technological settings to describe an electronic system that is intended to grant one or more forms of perception, usually to some type of computer system. A computer system, for instance, may be able to receive and respond to auditory and visual input. Human visual system. Understanding properties of human perception can help in designing algorithms and devices where either the end user is a human or even when there is a human somewhere in the loop. Human auditory system. Sound is transmitted by waves that travel through the air. The auditory system receives these signals and relays them to the brain. Structures in the sensory system take these waves and convert them into electrical signals. These signals are then sent to the auditory parts of the brain. Now we will study about analog representation of perceptual information. The emergence of digital alongside analog design media has created an interest in how the two intersect and differ. A traditional paper drawing can possess qualities of originality, authorship, and continuity of expression that may be lacking in a digitally produced drawing. Audio aficionados hold on to their collection of vinyl records based upon qualities of sound that they perceive. Digital virtual realities. Although analog simulations would be useful in the traditional architectural process, the poor cost-benefit ratio means that full-scale models are built rather infrequently. Did you know in 1986, the Joint Photographic Experts Group was formed from participants within ISO and CCITT? Let's now understand the digital representation and coding of visual information. A picture is worth 1,000 words. Information visualization is the method of presenting information as a visual representation to help in the understanding of unrelated data elements. This helps to correlate causal relationships of data into examples of meaningful information. Digital multimedia broadcasting, DMB. Digital multimedia broadcasting is a method of bringing multimedia images, radio, internet, and television to portable devices through digital radio transmissions. Digital multimedia broadcasting, both satellite and terrestrial transmissions, was adopted by South Korea in 2005. It's capable of running on band 3 VHF and L UHF radio frequency bands. Handheld digital video broadcasting, DVB-H, is the chief rival of this technology. When promoting this technology during a 3GSM conference in Cannes, LG Electronics emphasized that DVB-H makes for higher infrastructure costs since the technology is less compatible with Eureka 147 digital audio broadcasting, DAB, the standard for digital radio transmission used commonly throughout the world. Now we will study third representation and coding of visual information. Three-dimensional or 3D data visualization refers to a computer program or other technology that enables users to see a visual representation, whether static or animated, of data on their computer. Unlike other visualization programs, 3D data visualization is intended to be in 3D, which makes this visually different from other types. Information in the visualization can be either static or dynamic. The main difference between this and any other type is that all the visualizations are created in 3D, which gives them more depth. 3D visualization. This is an ancient art of creating graphic renditions of concrete things or abstract ideas. Early examples of visualization might include cave paintings, and modern examples exist under a number of categorizations, and might include the designs of buildings or vehicles. For instance, an industrial designer might design a line of lamps using 3D visualization and can test whether the lamps could be made efficiently based on the design requirements and available resources. On the other hand, car safety researchers can collect data from a test crash and create a model of the crash based on that data, then use the model to make decisions about future improvements. A hotel might want to create a virtual tour of its rooms so that potential customers could see the hotel's best features before they even arrive. Now we will talk about advanced multimedia coding standards. A codec from encoder-decoder or compressor-decompressor is software or hardware designed to both compress and decompress data streams consisting of audio and or video data. Compression both reduces the size of digital audio and video files, which means they take up less storage space and also transmit more quickly. Using 3D graphics to render a still scene is done in many fields for various reasons. Aside from artistic motives, some interior design or architectural software renders still scenes for the purpose of realistic visualizations. Marketing companies often use 3D designs in campaigns because the objects that are rendered are dynamic and can be reused consistently within 3D software without the need for repeated photo shoots. A number of MPEG standards are in current use, and more are sure to follow. MPEG 1. This first set of standards was developed for audio and video compression. Layer 3 is a codec within these standards, known simply as MP3, or the popular audio compression format for music. This video format was used to store movies on CDs, known as video CD or VCD. Quality is equal to that of a VHS tape, and compatibility playback on CD/DVD players is high. One drawback of this standard is that it only supports progressive footage versus the inclusion of interlaced. These terms relate to the way a picture paints itself across a screen. Progressive monitors, including progressive TVs, paint a picture from top to bottom progressively in a single sequential pass. Interlaced displays paint every other line and then fill in the odd lines in a two-pass process. MPEG 2. This standard improved on MPEG 1 by including the ability to encode interlaced pictures. It is widely used for digital cable, satellite, and over-the-air digital signals. This format is also prevalent for movies distributed on DVD. Television receivers, DVD players, and television stations typically incorporate this standard. MPEG 2 also contains two container formats, the transport stream and program stream. These relate to the way digital broadcasts are transmitted and formatted to media, respectively. MPEG 3. The intention was to make this standard compatible with high-definition TV, HDTV, but this became unnecessary when MPEG 2 extensions expanded that standard's ability to encompass HDTV. At that time, this standard was abandoned. Regulated by the Moving Picture Experts Group, MPEG, MPEG 3 refers to coding standards for high-definition television signals. The group is part of the International Organization for Standardization. Since 1988, the group has been responsible for creating both video and audio coding standards. There are several different advanced audio coding profiles. The file extension MP4 refers to a standard MPEG-4 file, while M4A refers an unprotected AAC. M4P is for protected AAC. The differences between files with an M4A or MP4 extension on the one hand and an AAC extension on the other hand are that the M4A and MP4 extensions signal container formats that have a tagging standard, and so can carry song and album information with them, which the AAC files cannot. Files with AAC extension are not accepted by many players. Still picture coding, JPEG 2000. The Joint Photographic Experts Group, also known by the acronym JPEG, is a technical committee which develops image standards. Video coding, MPEG-4. Since audio and video files are so large, a way of compressing them while maintaining sufficiently good quality was desired. In the quest for a standard to accomplish this, the Moving Pictures Expert Group, MPEG, was established in 1988. The result was the MPEG family of standards for audio and video compression, created under the auspices of the International Standards Organization, ISO, and the International Telecommunications Union, ITU. Several MPEG standards, such as MPEG 3, have been depreciated. The standards still in use are MPEG 1 and MPEG 2, used for video on CDs, DVDs, and digital television. MPEG 4 used for audio and visual data. MPEG 7 used for metadata, and MPEG 21 intended for digital rights infrastructure. Multimedia Content Description Interface, MPEG 7. Multimedia information is getting more abundant and the means to produce it are becoming a commodity, but finding and managing multimedia content is getting harder and harder. In 1996, MPEG started a project formally named Multimedia Content Description Interface, but better known as MPEG 7, acknowledging the need to efficiently and effectively describe and retrieve multimedia information and recognizing the substantial technological developments in the area of multimedia content description. MPEG 7 sets a standard for multimedia description tools, notably so-called descriptors, description schemes, system tools, and a description definition language. Let's take a look at the speech coding standards. Speech coding is the process of obtaining a compact representation of voice signals for efficient transmission over band-limited wired and wireless channels and/or storage. Today, speech coders have become essential components in telecommunications and in the multimedia infrastructure. Commercial systems that rely on efficient speech coding include cellular communication, Voice over Internet Protocol, or VoIP, video conferencing, electronic toys, archiving, and digital simultaneous voice and data, DSVD, as well as numerous PC-based games and multimedia applications. Speech coding is the art of creating a minimally redundant representation of the speech signal that can be efficiently transmitted or stored in digital media, and decoding the signal with the best possible perceptual quality. Like any other continuous time signal, speech may be represented digitally through the processes of sampling and quantization. Speech is typically quantized using either 16-bit uniform or 8-bit compounded quantization. Like many other signals, however, a sampled speech signal contains a great deal of information that is either redundant, non-zero mutual information between successive samples in the signal, or perceptually irrelevant information that is not perceived by human listeners. Most telecommunications coders are lossy, meaning that the synthesized speech is perceptually similar to the original, but may be physically dissimilar. A speech coder converts a digitized speech signal into a coded representation, which is usually transmitted in frames. A speech decoder receives coded frames and synthesizes reconstructed speech. Standards typically dictate the input-output relationships of both coder and decoder. Audio coding standards. With the introduction of the compact disc or CD in 1982, the digital audio media has quickly replaced analog audio media. However, a significant amount of uncompressed data, 1.41 million bits per second, required for the digital audio has led to a large transmission and storage burden. The advances of audio coding techniques and the resultant standards have greatly eased the burden. 10 years ago, nearly nobody believed that 90% of the audio data could be deleted without affecting audio fidelity. Nowadays, the fantasy becomes reality, and the ongoing coding technologies are inspiring new dreams. Now we will learn about text compression standards process. By introducing powerful standards for the compression, representation, and organization of digital video, the MPEG Group, a division of the ISO, made it possible for the widespread use of digital video. Currently, there are some digital video standards that the MPEG Committee has introduced. from MPEG-1 to MPEG-21, which is still in its early stages. MPEG-1, a standard used primarily in the storage of video. MPEG-2, the standard preferred by DVD and SVCDs. MPEG-4, designed with multimedia applications in mind. MPEG-7 describes all the different facets of a video. MPEG-21 creates a multimedia framework. MPEG-1, standardized in 1991, MPEG-1 is the oldest of the digital video standards produced by the MPEG Group. The purpose of MPEG-1 was to provide technologies and algorithms for the efficient compression of digital video. This was done to facilitate the transport and storage of digital content while maintaining quality. MPEG-2, which became a standard in 1995, is a higher quality version of MPEG-1. It was designed to be backward compatible with formats following the MPEG-1 standard and uses the same techniques that MPEG-1 does, like DCT, waveform, and entropy-based encoding. The difference in quality has to do with the tweaking that many of the technologies went through in order to produce higher bit rates and an overall higher standard of video. Because of its vastly superior quality, MPEG-2 was introduced for a purpose different than MPEG-1. MPEG-4, creating a thorough editing of video content, was not a major concern of MPEG-1 and 2. MPEG-1 especially was hard to work with, using only low-level editing. There was not very much of an encoder that they could do to clean up a video. People recognized that MPEG-1 and 2 were not adequate for representing multimedia, and therefore MPEG-4 was created. MPEG-4 is very functional. It can do many things with a great deal of information. These are the system's audio and visual functionalities. An MPEG-4 system addresses how to describe the relationship between audio and visual objects within digital content. These relationships are either on a spatial, temporal level or an object-to-object level. MPEG-7. The Internet is a powerful tool for looking up information, partly due to the power and convenience of search engines. Sites like Google and Lycos enable users to enter a string and then search websites for that string and return hits. This enables users to find information at a far quicker rate than ordinary searching would. The problem is that the current form of searching is text-based and is inadequate when searching for multimedia. MPEG-7 addresses this lack of multimedia searching. MPEG-21. The focus of the standard so far has been very specific. MPEG-1, 2, 4 dealt with the compression and the representation of audio-visual objects for storage and viewing, MPEG-1 and 2, and multimedia, MPEG-4. MPEG-7 broke the mold slightly by defining a framework for describing an AV object for easier search and retrieval. But in all cases, the quick and efficient exchange of information, like text and AV objects, relies on complex framework and nodes and servers that may not be on the same level and able to communicate adequately with each other. Currently, the work on MPEG-21 includes 5 elements that form the bulk of the standard. These elements are: Digital Item Declaration, DID, defines what digital content is and provides a model for. Digital Item Identification, DII, uniquely identifies DIDs through such technologies as IP addressing, and description schemes as defined by MPEG-7. Intellectual Property Management and Protection gives content providers tools to manage and protect their digital content from abuses like illegal copying and distribution. Rights Data Discovery, RDD. The RDD is a dictionary for legal terms, documents, case laws, and other pieces of information that REL uses. Data Item Adaptation provides a means to adapt or change digital content for transport across slower media and to destinations that are unable to handle the content at its current state.